Aloha guys, Dr. Tom is coming back at you again. Once again, we're going to continue our fascinating discussion. We're talking about the formation and drainage of aqueous humor in the anterior chamber of the human eyeball. Quickly, there's two chambers, a small anterior chamber that has watery aqueous humor, and a larger posterior chamber which has vitreous humor, which is a gelatinous-like material. Okay, back to the aqueous humor. It's formed by the ciliary body, circulates through the pupil behind the cornea, and drains through the canals of Schlemm, and then it ultimately ends up into the circulation or the lymphatic system. The important thing, guys, is if for different reasons the canal of Schlemm or canals get plugged up, you can develop glaucoma, which is a disease where that pressure builds, a fluid pressure, and it squishes and destroys the little delicate mechanisms in the eye. And the problem is it's asymptomatic until the damage has already been done in many cases. In other words, they already have permanent damage to the eyes and sight before they realize that they have glaucoma. It can be successfully treated a number of ways. If you ever go to the eye doctor or the optometrist and they blow like a little puff of air in your eye, poof, they're measuring the intraocular pressure to make sure that you, or they're checking to see that you don't have, or hopefully don't have glaucoma. Okay. Muscles of the eye. Extrinsic are on the outside, intrinsic are on the inside. Extrinsic move the eyeball around. Very complicated. How many cranial nerves deal with that? 3. Intrinsic move structures within the eyeball, which is the iris. The iris is the muscle that constricts and dilates the pupil. The iris is the colored portion of the eye. We have ciliary muscles inside that stretch on the lens or relax and change the thickness of the lens, and that's what changes the focus of the vision. Extrinsic muscle, we have 4 rectus muscles, 2 obliques. Primary innervation is cranial nerve 3, oculomotor, but there's also 2 other ones that play a big role too. So we have, let's see, there's 2 obliques. Yeah, here's an inferior oblique and superior. And then there are 4 rectus muscles the other way around. And this is able to give guys complete movement of the eye. To say it's complicated is an understatement, naturally. Okay, intrinsic muscle. Well, first we have the iris, circular muscle. Meiosis and muscatinic receptors, radiomyotraces, and the ciliary muscles. Okay. What they're talking about, guys, mydriasis and all that, when they, it's the name for when the pupil constricts or dilates. Okay. But they also, often when you go to an eye doctor, they'll give you medication. It'll make your pupils dilate so they can see in more easily. I had some training and all that years ago, and it takes a fair amount of skill to be able to look in someone's eye with an ophthalmoscope. It's a fantastic view when you do, because you can see all this wild stuff. But it helps if the pupils are dilated. I was hoping they'd have a picture of the lens here, but they don't. So far. Photopupillary reflex ciliary muscle. Pupils constrict when exposed to light. They should. And if you shine it in one, they both should. They should do it equal. The other eye's pupil also constrict. Ciliary muscle rise from the ciliary body. Okay. Refraction and accommodation. The ciliary muscles pull on the suspensory ligaments. The suspensory ligaments in turn pull on the lens. The lens changes shape, which changes its focus. So when you pull on it, it thins it, and when you relax, boing, it goes back to its shape. Accommodation is when you take an object, and as you move it closer to a person and instruct them to keep their eye on it, their eyes will cross like that. Okay. Refraction is basically the proper focusing of the eye, bending light rays to focus on the retina. The lens is the primary refracting structure, but also the cornea plays a big role too. The lens is the primary, here it is here, but the cornea also plays an important role. Now, if you don't have a lens in your eye, or if you took it out, the light waves are parallel and they converge on the retina back here. But this would give very poor vision. What we want, guys, I mentioned this in the last video, is we want this stuff to converge to a pinpoint focus right on the retina, focal point. This gives the sharpest vision, right on the macula. What is it? I can't remember. I will in a minute, though. Stimulation receptors. Night vision is rods. Color vision is cones. I wish they would have had a diagram of the lens. That's a lot more important. Maybe they still do. Okay. All right. Here it shows the eyes, the photoreceptors. What it's showing here, guys, is that some of these cross over and some of them stay on the same side. It's really complicated. This is called the optic chiasm. The two optic nerves come back and cross here and kind of junction and go on back into the visual cortex of the occipital lobe. But some of it stays on the same side, which is called ipsilateral, and some of it, the nerve portions of the nerve, cross over, and that's called contralateral. Photoreceptors, rods and cones, generate nerve impulses. Nerve impulse travels along cranial nerve 2 to the visual cortex. The occipital lobe is what sees the dog. Guys, this is, to me, it's really important. I mean, whatever. But again, all that's out there in the world are various frequencies of electromagnetic radiation. Color and all that is what we call it. In other words, we see blue because we've been trained to see that particular frequency and call it blue. Blue is not an inherent quality of the world. It's all interpreted back in our vision center. Okay, how seeing occurs. Pathway of light goes through the cornea first. There's some acuity that's given to it there. Then it goes through the aqueous humor, the liquid, through the pupil, through the lens, through the vitreous humor, and on to the rods and cones. Rods and cones are stimulated. That stimulation is passed on to cranial nerve 2 and ultimately the occipital lobe. Errors of refraction. This is the reason people have to have corrective lenses. One of the most common is nearsightedness, called myopia. The focal point is in front of the retina. You can see well, usually with myopia, you have good near vision, but poor distant vision. This is real common. Hyperopia is the opposite. It's farsightedness. The focal point is behind the retina. They can see well at a distance, but not as well up close. And then astigmatism is where there's a misshapen eye, primarily the cornea. The cornea is real important, guys. I've tried to kind of bring it out a little more. So astigmatism is where it's actually misshapen. Now, all of these can be corrected with lenses or contact lenses or glasses. They're not going to show it. No, they're not. Okay. Now, I'm going to tell you a quick story. Doctors will tell you that exercises for the eye do not work, and they will not correct vision defects. And I'm here to tell you that sometimes that's wrong. How do I know? Because I did it. That's how. When I was young, I had 20/15 vision, which is better than normal. When I was in the Army, I had very sharp vision. When I was in my doctorate program, I had very sharp vision, 20/15. 20/20 is normal. 20/15 is better than normal. Years later, out in practice, being under artificial lights or whatever, I got where I noticed I couldn't see well at a distance. I had myopia. So I wore corrective lenses. I wore glasses. These are reading glasses here, by the way. They're just over-the-counter reading glasses. Where was I at? Back when I was in school. No. So for, I think, 20 years, I wore glasses. I didn't have to wear them. I had to take them off to read, but to see the distance clearly. And I began to notice that under certain circumstances, I could see quite well at a distance. And I thought, now, if I can see good part of the time, I can see good all the time. And I finally found some exercises that worked. And now, for years now, I've had 20/20 vision. Surprisingly, though, as my distant vision improved, my close-up vision got poor and had to start wearing reading glasses. But I'd rather wear reading glasses than have to wear regular glasses all the time. So yes, under certain conditions. Now we got to move because we're going to run out of time. Vision loss. Any defect along the pathway from the cornea brain can do it. Scarred cornea, cloudy lens is called, what is it called? I can't remember. But they often have to remove it. Errors of refraction, that's what we've been talking about. Eye reflexes, corneal reflex, it should blink. When you shine a light in there, yeah, it should adjust. Okay, they covered the eye. I wish they'd gone into a little more detail. Cataract is what it's called when the lens clouds over. Very common in older people. Also, too, older people get what they call presbyopia, where they can't see up close. So because my vision is 20/20 and it's been that way, and because I'm an old dude, I think wearing reading glasses is presbyopia. Okay, here's the ear. Outer portion is called the pinna. Here's the external auditory canal. Here's the eardrum, which is actually called the tympanic membrane. There's 3 little bones in the ear, malleus, incus, and stapes. When sound waves come in, makes an eardrum vibrate, vibrates the oval window. Here's the structure. The cochlea is for hearing, the semicircular canals are for balance. Pretty wild. Here's the external ear, here's the middle ear, and here's the inner ear. Middle has eustachian tube, that's important. That's the tubes that connect down to your throat. So, when your ear, it helps equalize pressure in the ear. When you swallow, sometimes you'll hear it go, ee. Inner ear has the cochlea, the vestibule, semicircular canals, and the origin cranial nerve 8, vestibulocochlear nerve is the cranial nerve that controls hearing and balance. Eustachian tube connects throat with the middle ear, equalizes pressure across the tympanic membrane. In young adults, short and horizontal adults, it's longer and more vertical. Receptors, organ of Corti. Mechanoreceptors are hairs in the cochlea in the middle ear, and sound waves make them wave, and that wave is converted into impulses that go to the temporal lobes of the brain. Organ of Corti is in a fluid called endolymph, cochlear branch of cranial nerve 8. So when that transmission, that vibration, guys, is sent on through here, and it sets up nerve impulses in cranial nerve 8, and that's how we hear. Now again, moving noise is made by movement in the atmosphere. That's not sound. Sound is once we hear it and process it in our temporal lobes. Sound waves go to the eardrum, tympanic membrane, the ossicles, the little bones, oval window, organ of Corti, pathway of nerve impulses, organ of Corti, cranial nerve 8, the cochlear branch into the temporal lobes. Hearing doesn't happen when what? Sound waves. I'm not following them here. Well, if the vibrations are not set up properly, it won't happen. I'm not quite following. Sorry, guys. Okay, now we're going to talk about balance. Mechanoreceptors are in the vestibular and semicircular canals. These things here. Hairs in the endolymph. This is the vestibular portion of cranial nerve 8. So the cochlea looks like a snail shell, controls hearing. The semicircular canals and all that and vestibule control balance. Types of equilibrium, static, maculo-otoliths. We also have little tiny rocks in there, which are what otoliths are. Dynamic, let's see, semicircular canals, crystal, okay, yeah. We're finished up, okay. Just in time. Yes, guys, I tried exercises for the eyes before, and it didn't do much, but I finally got the right one. If you want to know, I'll let you know. But yes, indeed, it worked. I haven't done them in a long time. I still have 20/20 vision. So you question everything. That's what I say. All right, guys, we're finished up. This finishes up everything for week 4. We'll see you next time. Be there or be square. Dr. Tom signing off.